Next up, we have a remote speaker. We have Justin James from iRODS is going to give us an update on the iRODS connector. So the iRODS team has worked with us over the last couple of years to get the iRODS system integrated with Globus, or working with Globus. And we've made some recent changes. I'm going to have Justin walk us through those.
So I'm going to talk about the iRODS Globus connector. The first thing I'm going to talk about is what iRODS is. You know, everyone here knows what Globus is, so I'll get to that. So this is just going to be a quick iRODS overview, just a few minutes. iRODS is the integrated role-oriented data system. It's open source software. It's distributed and metadata driven. So we like to say that we try to do as much as possible through metadata as we can. And it has basically four main components to it: data virtualization, data discovery, which is the metadata part, workflow automation, which is a rule engine, and secure collaboration. And I will go over each of those in the next couple slides. First, we like to think of iRODS as an integration layer, so it can integrate your existing infrastructure with your iRODS clients. So we can integrate iRODS with your existing infrastructure. So for example, you may have storage nodes and compute nodes. You may have indexing framework, things like that. And iRODS can connect all of those with the various iRODS clients. The command line being the iCommands. WebDAV is a possibility. Metalinks is a web app that we provide, and it's also open source. And but a lot of clients also write their own web interfaces. Okay, the data virtualization. It's basically, iRODS is kind of like a virtual file system as far as the data virtualization goes. We have collections, we have data objects, and those are roughly speaking the same as directories and files. The only difference is the data objects themselves can be replicated to multiple files on distributed, geographically distributed servers. And it'll be presented as one data object to the user, unless they're looking specifically for the details, like a long listing of what where the data object exists. And that replication, things like that, can be automatic. So the user just uses it similar to a file system as far as changing directory, writing files, things like that. Oh, and the physical paths, which are actually where the data is stored, that could be either a POSIX file system, or it could be, object store like S3 or tape. Okay, data discovery. This is the metadata portion of iRODS. And basically, you can attach metadata to any first-class entity within an iRODS zone. So an iRODS zone is your installation of iRODS, which will have a database with it and multiple resource servers that serve up files. The data objects can have metadata, collections, or directories, whatever you want to call it. Even users and storage resources can have metadata. You can automatically, you can have policies that would automatically write metadata via the rule engine if you wanted. So if someone uploaded a file and they wanted to have the contents of the file stored in metadata on the data object, they could do that automatically. And that would make it easier to discover the file, to find what's in it, things like that. Or you can manually create the metadata too. And this metadata is different than system metadata, which iRODS also has, like file size, things like that, update time. But this is user-defined metadata. Here's another example, just metadata everywhere. The resources, the files, the users, everything can have metadata. Okay, workflow automation. This is kind of the meat of iRODS. This is the rule engine. So whenever anything happens in the system, it will trigger policy enforcement points. And you can write code around those policy enforcement points to do whatever you need to do, whether it's restrict access, although iRODS does have, it's built-in access controls, but you can, like I said, read the file and write metadata if you want with the rule engine. But anyway, any operation like authentication, storage access, database interaction, network activity, those are all have policy enforcement points associated with them. And these rules can be written in the native rule language, but as of the last 5 years or so, there are other rule language plugins, so you can do it in C++ or Python. The user community may have created other rule languages for rule engine as well. These are the three that we support as far as our integration testing. And my computer is being very slow, so I'm trying to move to the next screen. Okay. So here's an example of what I just said. So we have someone does a put file upload, and it will, before the actual file is uploaded, you'll do a PEP data object put pre, which is the policy enforcement point that you would want to use, and you could write any code, write your Python code there, and the put would happen, and then you'd have a post policy enforcement point as well. Okay, finally, the secure collaboration that just lets you connect to other installations of iRODS, so different institutions can temporarily or permanently, whatever they want, they can collaborate and share information. So two different iRODS zones can connect to each other. And it's as simple as sharing a couple of keys and creating a local user to represent a remote user. Okay. So that was a quick introduction to iRODS. Now I want to talk about the Globus Connector. So the iRODS Globus Connector is a plugin to Globus, uses the standard plugin interface that Globus provides, and but it's a client to iRODS. So anytime someone does a put or get of a file or needs a checksum or something like that, that will go through the Globus Connector, and which will connect to iRODS via the iRODS client C API. And important point is that all the policy is still active, so you can still have all your policy on your data that you've created, and the data can be written to S3 to the cloud. It can also just be on our local resource for a Unix file system, a POSIX file. And basically iRODS just appears as a file system to Globus. Okay, I'm sorry, my computer is really slow. So real quick, just how this is implemented. A lot of people here probably know all of this, so I'll go through it quickly. We just implement the Globus GFS storage interface, and specifically the things we've implemented were the init, destroy, send, receive, command, which I'll have more on the next slide, and the stat. And these all just make iRODS calls, so they, init connects and logs in, destroy cleans everything up, calls disconnect, things like that. Okay, the client commands themselves, make directory, remove directory, delete an object, and checksum are the ones that we support. And I'll talk a little bit more about checksum in a couple of slides. It says next slide, but it's actually two away. So some things we've done recently, recent enhancements to the connector. Like I said earlier, the original plugin was written by EUDAT, the European Data, I forget the acronym, but they wrote it, and then it was taken over by the iRODS consortium. So we now test it and make improvements to it. So one thing we've done is we've migrated the code from C to C++. That's so we can use a lot of the newer C++ client libraries that iRODS supports. But also it just makes things like cleaning, memory cleanup and resource allocation and cleanup a little bit easier. But we still use the C interface into Globus. We also improved how the file hashing works and improved upload and download performance, which is probably the biggest improvement we've made in the last year or so. We also added support for incremental directed listings. So if you list a very large directory, either on X number of entries or Y seconds have passed, we'll send a partial listing. Heartbeats for long-running checksums, and implemented the realpath feature. And finally, we fixed some memory leaks in the existing code and minor bug fixes. And I have to thank Michael Link for giving us, helping us, telling us what changes need to be made. And also, he actually did make some of these changes, specifically the memory leaks and bug fixes. He helped us on that. Okay, checksum and hashing. Originally, we used the plugin used the iRODS hashing scheme, which is mainly just to verify the validity of the data on transfers. But iRODS only supports MD5 and SHA-256, and Globus supports more hashing algorithms than that. In addition, it's kind of a single setting in iRODS. You enable one or the other, so the user cannot define what hashing he or she wants. So to fix that, we no longer use the iRODS hashing scheme. The actual plugin actually calculates the hash itself, and it stores the hashes in metadata in iRODS. With the time that the checksum is calculated, so anytime any data object is updated after the last hash has been calculated, it will calculate a new hash. And finally, file transfer improvements. So the original connector did not have very good performance for file transfers. There were some, it was not multi-threaded, and there were some bottlenecks. And obviously, if you're using Globus, you want efficient file transfers. So we did improve that. We kind of bridged the way iRODS does transfers and the way Globus does transfers together, made it multi-threaded. And by doing that, I've just given you one comparison here of a bunch of testing we did. So, fairly, not huge file, but fairly large 5G file, using three threads for transfer. The upload performance improved, and this is also using local storage, so there wasn't really a network involved with this, but I think it still gives you an idea of how much we've improved. The upload performance improved for 5G file, improved from 31.6 seconds on average to 9.9 seconds, and the download improved from 28 seconds to 11. So quite a bit of an improvement. And the download performance, just for reference, peaked at 6 threads at 9 seconds, or 555 megabytes per second, or megabits per second, sorry. Oh, no, that's bytes. Okay, megabytes per second. And that's all.
Great, thank you. Thanks,
Sure.
Justin.